now time to start. So, so let's just follow what we are going to discuss. We were going to discuss yesterday. Which is the three main characters in the photogrammetry. So, any idea? There are three characters in photogrammetry. So, well, that's okay. Let's start from some brief introduction or some reminder there. So photogrammetry is actually a technology for you to use a camera and to perform some measurements so that we can obtain the three-dimensional coordinates of some target features in the object space. So that's the main idea, or the main, you can say, functionality of photogrammetry. But when we want to do that, we need to first understand how an image is taken. So we need to understand. So when we take an image, why this image, why the content on the image arranged like that. So that's the first thing that we need to discuss, which is the imaging geometry. So how the image perform, how the image is taken. So when we want to discuss that, what are the main characters when we are talking about photogrammetry? The position of the what?
Of the photo taken.
Of the what?
How you take a photo?
How I take a photo?
Yeah, from above or in the ground.
Okay. So how I take the photo? You mean the position of where you are taking the photo?
Yeah.
Okay. So yeah, that could be one. So one is the camera position, or yeah. So let's just say camera. Camera, of course, is one. So if we are going to talk about photogrammetry, the camera is of course the main character over there. And beside that, any other things? Yeah. It's
The object.
the object. So what do you mean by object?
The object that we want to take.
The object that we want to take the photo. Yes. Right, yes, the object. Right, the object that we want to take the photo, and specifically in this course, we are talking about the precision, the location of that object. So yes, these are the two main characters. And any other things?
Light.
Light? What do you mean? Light.
The light of object.
Light of object. What do you mean by light of object?
Go through the
Energy source.
energy source. Yeah.
The energy source. The energy source can be considered, however, when you are talking about the photogrammetry, specifically from the imaging geometry, how one image appear, where an object appear on your photo, for example. The light source may not be the most critical thing to be considered. For example, it doesn't matter whether it's an active sensor or passive sensor. Where an object appear on your image, then actually that doesn't really matter. Okay. So any other things? Sure. Well,
Maybe feature or control point.
feature or control points. Control points. When you are taking a photo, you don't need you don't necessarily need a control point. Yeah. 蔡宗翰，是吧？蔡公颖，sorry. Yeah. The image coordinates. What do you mean by that?
How do the image, where the image is positioned?
Where the object locates on the image, right? So the third character is image, right? So when we are talking about the imaging geometry, or when you are talking about, say, how photogrammetry works, actually these are the three main characters that you are going to consider. And that's the first question I ask you guys to think. And the second question is, okay, so right now when I am taking the photo, then how can these three interact with each other so that we can have the imaging geometry. So let's just say, let's define it first. For example, one object the object could be have x, y, z coordinates in the object space coordinate system. And for the image, then usually you will use the small x and small y to represent it. So it will be the coordinate system on the two-dimensional image. Okay. And in terms of the camera, because right now we care about the geometry. We care about the geometry instead of the content on the image. So the camera precision. So earlier we mentioned that the camera we care about the precision, and the precision actually includes, for example, XC, YC, ZC, omega, phi, kappa. Right. Omega phi kappa. So these 6 parameters are usually called EOP, exterior orientation parameter. Exterior orientation parameters. Okay. So in Chinese, it's called exterior, Chinese, of course. Exterior means Y, outside. The idea is outside. Orientation is 方位, right? And parameter is 参数, right? So exterior orientation parameter, Y 方位参数. So in short, we usually call it EOP. So XC, YC, ZC, and omega phi kappa, what are those things? So here, the XC, YC, ZC means the C indicates the camera. So that means where the camera is. So you have a camera, right? So where the camera is, that's the location. And however, the camera has the angle, you can say the shooting angle. So that is defined by omega phi kappa. So if right now, okay, so that's defined, okay, so pay attention, that's defined what omega phi kappa is. So right now, here we have an airplane, and right now, if we define that if we have an airplane, and then on the airplane, we have the camera. So if we define x-axis is the flight direction, and the z-axis is the sky. Then from the right hand side principle, then we have the y direction, right, y-axis. So the definition of omega phi kappa is omega is the rotation angle along the x-axis, which is this rotation. Okay, so this is x-axis. So omega is defined as how many degrees that you have rotated according to along this x-axis. So phi is the rotation angle along the y-axis, right? Which usually is considered as the tilt angle. Okay. So and then the kappa is the rotation angle along the z-axis, which is this angle. Okay. So with the omega phi kappa, then you can define where that camera is aiming at. Okay. So the EOP includes the XC, YC, ZC to represent where the camera is. Then omega phi kappa define the orientation of that camera. Okay. So some people may be confused about why we use omega phi kappa. There are of course other ways to represent the camera orientation. There are other ways. Then we will introduce that later. But however, the reason, let me just tell you. The reason that we use the omega phi kappa is because it's easy for the mathematical calculation. It's easy for mathematical calculation. It may not be easy to visualize. Say, oh, okay, rotate omega for how much degree, rotate phi for how much degree, and then and the kappa. It may not be easy to visualize. But however, it's easy to calculate in a mathematical format. Okay, so these are the EOPs. So right now, let's define the parameters for them. And the next question is, so how these 3 characters interact with each other to form the imaging geometry. For example, if you have one object, if you have one object, for example, like over here, if you have object over here, and it has the x, y, z coordinates, and then right now I have a camera, and this is the camera location, this is the camera orientation. So I take a photo, then supposedly this x, y, z will project to one image, an image over here at the x and y imaging coordinates. So that is the imaging geometry that we are going to consider. Okay, that is the imaging geometry we are going to consider. So from the geometric point of view, we can visualize it kind of like this. So on the ground, okay, on the ground, here we may have, for example, like a certain point over here. This is the A point. And so this A has the X A, Y A, and Z A. Okay, so this is our object. And then we have a camera over here, for example, here, and aiming at, for example, this. Right. So this is our camera location. So when we are defining the camera location, usually we call it we have a name for that. Perspective center. Alright, we usually call it perspective center. In Chinese, it's called 透视中心. Center is 中心. 介绍一下, right? So you guys should know it. Perspective, in the translation currently, in this context, it's called 透视, right? 透视中心. Right? Or sometimes you can call it projection center of the camera system. It's a projection system, projection center. But usually the formal term is perspective center, okay, right? Or the camera location in general. Okay. So this includes, well, basically this is described as the with the EOP. So it has the certain EOP. EOP is over here, right? So the XC, YC, ZC, and omega phi kappa. And here, what this is the image. So I use this to indicate the image. But however, I believe you guys should have the ideas that there are two ways to draw the image location. One way is to draw it like this, and the other way is to draw it like this. Okay, so supposedly, the camera system is like you have a lens. So the camera system, you have a lens, and then you have the film behind the lens, and you have objects, at the front. Okay, so object, lens, and your image frame, your image film is over here. So the geometry supposedly should be like this. But however, so in this case, that means the image film is over here. This is called negative. Negative, right? Right. Spelling is very bad because of the damagement from technology. Autocorrect, right? Alright, so if your film is over here, that is called negative. In Chinese, it's called 负片. 负片. Okay? So I believe you guys have seen this before when you are in your childhood. You have like a roll of films of film, and then if you pull it out, then it's like kind of transparent-ish, and then the color is totally different from the real object, and that is called negative. Right? That is film, and then if you draw it like this at the other end of the objects, then it's called negative. And then if you draw the image over here, then this is called positive. positive. Right? 正片 in Chinese is called 正片, right? 正片 and 负片. So both way to draw, for example, to draw the image location is fine. Right, it's fine actually. So I'm not talking about it. I'm talking about this. Both way are fine. Okay, so but however, I usually enjoy like the positive way because, like I said, if you are talking about the negative, then the color tone, color tone, and also the location of the objects, they are totally different from the real world, right? But however, if you draw the image, the space like this, then this A point is over here, and if there's another point, for example B point over here, then A and B will be like just a different scale. Like you just like shrink the scale and then to become this. So it's easier to visualize and it's easier to imagine, right? Just it's easier to imagine. So yeah, it's easier for you guys to understand. So I usually draw the image space as the positive. Okay. So then, what is the imaging geometry? The imaging geometry is that. So of course, light. Oh. The guy said light is gone. Alright, so there's some send some energy to the object point, the feature. Then it will reflect some energy, and then those some of the light ray will toward our perspective center, and then after that you will send it to the film. Okay, so there is a specific light ray. Right. Drawing is not so good. Right. There will be a specific light ray